Good morning, everybody. Hello, everyone out there. Good morning. Good morning. I'm so proud to see all of you joining. Wow. Makes me feel important. Good morning. It is now 9:56. We got about 4 more minutes. Good morning, everybody. Good morning. Morning, everybody. Starting 10 o'clock sharp. Listen, this morning we're going to be looking at our do now, and we're dealing with starting off types of transformations. What's another word for transformation? Transformation means to do what? Drop it in the box. What does transformation mean? If I am to transform something, what am I going to do? Transformation. What are we doing? Write your answer. Drop it in. When we transform something, what are we going to do? We're thinking about doing what? Wow, 34, go live. Change. I love it. I love it. Transformation. Change. Here are your terms that were in your packet. You had translation, rotation, dilation, reflection, vertical, horizontal, y-axis, and x-axis. Now, okay, y'all, what's the word for translation? When we're talking about translation, what are we talking about? Sliding. We're going to slide something. We're going to change it by sliding. What are we going to do for rotation? We're going to turn it or spin. Dilation. What are we going to be doing? We're going to be shrinking or enlarging. It's a reflection. What do you think reflection is? Flipping. Another word could be flipping. We flip the image. Vertical. What do you think vertical means? Well, when we think of the coordinate plane, we think of vertical as being what? A vertical line, meaning that it's a straight line going this way. Vertical. Up and down. Horizontal. When we talk about a horizontal line, what are we talking about? A line running this way. The y-axis. What is the y-axis? Y-axis is the what? It's the vertical number line. That helps form the what? Coordinate plane. And when we speak of the y-axis, we are talking about the horizontal number line. That runs straight across. That's your x-axis. Okay, the question for today is this. This is your question for today. Drop in your answer. If you pull up your sheet for day one opening, you will see that. Drop in your answer. Which one of those transformations are we using here? You're going from this, you have this image, and then you went to this image. What are you doing when you're going from this to this? Which one of those terms this morning would be it? Drop in your word. What would you say? What is it called? Which one of those terms that we had this morning would be that? Huh? This comes from week 3. Week 3, day 2. Week 3. Good job, Golden Nuggets. Dilation. Great job. Great job. Thank you. Dilation is the word. So you'll see here that you are shrinking this. You're going from a larger to a smaller, and the word is dilation. And the second question on that sheet, day 2 opening, week 3, it says, describe the transformation from figure 2 into figure 3 using words from the word bank to the right. These words were your words from your word bank. Which one of these words would you use to describe the transformation from figure 2 to figure 3? From this to this. What words can we use here? What is it called? Write it down. What words would you use from that? I give you a hint. It's at least 3 of these. So what did you do to get from this point to that point? What did you do? Put your answer in. What did you do to get from 2 to 3? Okay. You reflect across the y-axis. Okay, moving right along. Let's we go to the second day 2 task, extended math, that I sent you. Pull it up. I sent it to you on your feed, on my feed. Extended math, day 2. Go to that sheet. Give you a few minutes to get it. I don't know why my sheets always tend to be leaning. Something is wrong with my board. I don't know if they help. Still just as worse. Okay, let's move on. It says, is the quadrilateral with vertices a rectangle? Is the quadrilateral with vertices -6 and 2, -3 and 6, 9 and -3, and 6 or -7? Is it a rectangle? Explain. At this time, what I would like for you to do, I'm going to give you a couple of minutes. I'm going to let you begin plotting these on the coordinate plane. Draw you one. Tell me, is it a rectangle? Is it a rhombus? Is it a what? Square? What else? What would you say it is? Plot those points and tell me what you think it is. What shape would it be? It is now 10:08, 10:10. I will come back. You can't see it. Hold on. I'm not moving this anymore. I'm going to move it one more time. You should have a sheet that I sent to you. A -6 and a 2, a -3 and a 6, a 9 and a -3, and a 6 and a -7. Plot those. Okay, let's look at it together. Okay, you got a set of points here. A -6, a 2, -3, a 6, a 9, -3, a 6, and a -7. Let's look at that. First of all, you got to know that this is the X and this is the Y. So we find it here. This is the x-axis. So therefore, we'll look on here for the x, and we'll look here on the y-axis for the y. So let's plot the first one. A negative 6. We'll drive over where we started the origin, 0, and go to a negative 6. And we go up 2 on the y-axis because this is the y-axis. And so we go 2 up. That'll be 1, 2. So there's 2 steps up. And we plot our point there. So this will be a negative 6 and a 2. All right? Then we got to find a negative 3 and a 6. So what we do, we go here and we find our negative 3 and we go up 6. So we count up on the y-axis 1, 2, 3, 4, 5, 6. So our point should be right in here. So this is a negative 3, 6. 9 and a negative 3. The x-axis is a 9. So we go over, because it's positive, we go over 9. And a negative 3, we come down. It's a negative 3, so we come down 1, 2, 3. So our point should be here. So this is a 9, negative 3. And these are my order pairs. And this is a 6, negative 7. So it'll be a 6 and a negative 7. So we drive all the way down, and where the 2 points meet is where the dot would be. So this is it right here. So this will be 6, a negative 7. So now I connect my dots. So you do the same. So now here I know that I will have, it looks like this. First of all, did you say this will be a rectangle? What did you say? Do you think this is a rectangle? Someone says it's not a rectangle. Okay. Anybody? What you think? Someone says it's not a rectangle because it don't have equal sides. Does it have to have equal size? All equal size or a pair of equal size? What does it have to have? Think about it now. A rectangle. You're thinking of a square. Ooh. Messed up that. I can't draw it straight, I'm freehanding here. And my ruler. So is this a rectangle? Is that a rectangle? What you say? Is that a rectangle? Yes, it is. Because it has 2 pairs of equal sides. These 2 sides are equal, and this side and that side is equal. Now I'm drawing free-handed now, so I might look a little bit off, but these 2 supposed to be congruent, and these 2 are congruent. It's a rectangle. So, what do you know about the angles of a rectangle? How many angles does a rectangle have? How many angles do you think we have in this rectangle here? How many angles do you see? Draw them in. Tell me how many it has. Write it down. How many angles does this rectangle consist of? Anybody? 4. Thank you. Thank you. Good job. Good job, y'all. Now, has 4 angles. And here is one. Here is one. Here is an angle. And here's an angle. What else do I know about these angles? What kind of degrees are they? It's a right angle. And how many degrees is it? Write it down. Drop it in the slot. How many degrees do we have here? That right angle is what? How many degrees? 90. Thank you. 90 degrees. Good job. So, we know that it is 90 degrees. So now, according to your paper, if you look at your paper, it said extended math application. It asked you, was that a rectangle? We found that. We said, yes, it was. And it says explain. Now, we know it's a rectangle because it has two congruent sides over here. We got these two sides are congruent and these two are congruent. Now, and it has 4 right angles. Now, if you look in the box, you will see it says, you may want to consider using what you know about the Pythagorean theorem. What do you know about the Pythagorean theorem? What do you know? If we were to apply this, what are we going to be doing? What's the formula for that? What's the formula for the Pythagorean theorem? Is that true? Okay. Now, I want you to look at another sheet that I sent to you called Extended Math Application. Look at a sheet that I sent you called the Extended Math Application. When you find it, say yes, so I know you got it. It has a coordinate plane on it. Good job, y'all. All y'all doing great this morning. The sheet that I want you to, I don't have page numbers on my sheets. So the sheet that I want you to find, it says Extended Math Application. It says below is a picture of a quadrilateral labeled PQRS with the 2 diagonals added, along with points M and N, which will help to calculate the length of 2 diagonals, line PR and line QS, using the Pythagorean theorem. Okay, do you all have that? It has points on it already labeled. Do y'all have that sheet? Type yes or no. Come on now. Extended math sheet. Starting off with below is a picture of a quadrilateral. We're talking about this quadrilateral PQRS. I send it to you on my feed. Look at it. Pull it up. You got it? But we're going to continue using what we got here on the board. We're going to still use that diagram. Okay? Oh, I tried to show you how it looked. Ooh. Do you have a sheet with the coordinate plan? And you got some points. You got this diagram that we just drew on that sheet is labeled, let me see here. It's labeled P. This point was called P. This point here was called Q. This point is R on that sheet. And this is S. This would be S. Do you see something like that you have? See if you got that sheet. Your rectangle on that sheet is already labeled. It's labeled PQ. That quadrilateral, which is a rectangle, is labeled PQRS. And it says it has two diagonals. Those diagonals, remember, the line like a hypotenuse, a line that we call a diagonal. Inside, if you can look on my feed, you can find it. I can't really show you how it looks. But it says extended math application. I sent it to you. Look on my feed. Okay? We finished the day two task, extended math, but now we're going to go a little bit further with the extended math application. This was another sheet. You got it. And this sheet dealt with diagonals. I mean, it wanted you to find the line, the length of two diagonals, and your diagonals were your lines joining or running across. Can't draw freehanded, you know. These were your diagonals. One thing we know that they intersect. They cross at a certain point. I can't draw straight, but they intersect right in there. They cross each other at a certain point. Okay? So, let me see where you are. Do you have that? Don't have that? I know you got it because I sent it to you. And it reads, below is a picture of a quadrilateral labeled PQRS with the two diagonals added. And I added them in the center, along with points M and N, which will help to calculate the length. We're trying to calculate the length of the two diagonals, line PR and line QS, using the Pythagorean theorem. You already told me the formula was a squared plus b squared equals c squared. Those diagonals are nothing more than your hypotenuse, the longest side of your triangle there. Okay, well, I tell you what, just draw on your paper if you can't find it, but I sent it to you. So, use the same thing we did for the one we just finished that I got up here. Draw from P to Q to R, and from Q to S. Draw a diagonal. These are diagonals going from point to point. You got two. Now, what is it that they want you to do? They want you to calculate or find the length of these two diagonals, PR and QS. They want you to find the length. Right off the paper. Find the length of the two diagonals. Line PR and line QS. How do you think we might go about doing that? Now, they ask you to use the Pythagorean theorem. So, what do you think you might do? Well, first of all, they added some more points to that particular sheet. And at a -3 on that sheet, they gave you another point, which was M. I gave you a point here, and they call it M. They also gave you another point, which was N on their sheet. And it went right in here. I'm going to write it with another color. And that was N. And you got your Q. You got your P, M, R, and S. Now, I'm going to try to make this as clear as I can for you. I'm going to try to trace it with another color so you can actually see the diagonal and which triangles it makes up. Hold on. When you look at that shape, you're dealing with okay, and this is the diagonal, but I'm going to go on and put a red line right up under it so you know we're talking about this. That's PMS. So, another one, the other one they are talking about, if I can do it for you, they are talking about, no, PMR, PMR. And the other one they connected with, the diagonal, is going to be NQ and S. It's kind of hard doing this stuff up here. I'm trying to get it so you can see it. They are dealing with these right here and these two. Okay? But these are your diagonals. Same thing. They are crossing they're bisecting. They're crossing each other, but they want to know the length from Q to S. And what's the length from P to R? So, when we look at this, the length from P to M is, you got to count your blocks. How far you have to go to get to M. 1, 2, 3, 4, 5. So it looks like to get from P to M is 5 spaces. So if you know that it's 5 spaces, then you can say from P to M, which is going to become PM. So PM is equals to 5. Now, also, this triangle consists of M and R. How far is it then from M to R? You got to count your blocks. You go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, what? 15 spaces. So MR going to equal to 15. Okay? Now, since P was a -6 and a 2, you remember? P was a -6 and a 2. And M was what? A -6 and a -3. That's what M was. And R, so R was what? A 9 and a -3. That's what R was. So, the same way then, you're going to know then that Sn, you're going to count from S to N to find out how far it is from that space to that space when we get to that particular triangle. But let's work with this one first. But remember in the beginning, it says apply the Pythagorean theorem to this particular triangle to try to find out the answer. Remember that? It says apply the Pythagorean theorem to it. Pythagorean theorem to figure it out. So you knew that a squared plus b squared equals c squared. So knowing that, what could we have done? So we're trying to find out c squared because this is the hypotenuse. We don't know that. We know, let's say that we say this was PM. PM, they just using that because this is part of that triangle here. So really, we might look at it and say A. This might be A squared according to the Pythagorean theorem if that's what we want to say. We might say MR is the same thing as B squared. But it doesn't matter because you can use either or, okay? So we plug in the information here. We don't know what this line is. That's your hypotenuse. So we use that as c squared. So because we don't know, we could say, all right, well, we could use the formula. We could say that line is PR. So I could say, I don't want to confuse you here. I could say PR square, which is that right there. And that's the diagonal. I'm going to call it PR square. And that's the same thing as saying C square. Because you remember, the hypotenuse is the longest part of this thing here. And it's considered C. This here is A. It could be B. It doesn't matter. Either or. It doesn't matter which one it is. So C square is equals to PM right here. I'm using their terms that they got it labeled. PM. But we know we're going to say that is A square for us. We're going to say PM is the same thing as A square. So that can be PM square plus, if we look at theirs and we say plus what? We'll say, okay, plus B square. But their B square is MR. So we're going to say MR square. They just using what they got for their triangle here. But we're going to use, I'm just putting it in our language. C square equals A square plus B square. That's the same thing. PR square is the same thing as C square. That's the hypotenuse. We don't know the value of that. But we found out, though, that PM square was 5. So A square could be 5 here. So that'll be 5 square plus, and that's same thing as PM. Same thing. That's going to be a 5 square. They're just using the letters from your triangle. So that's going to be 5 square plus our B square we found was 15. So 15 square. So now we know that C square equals 5 square plus 15 square. But we have to solve that. But don't forget now, it's the same thing as PR square. That's your hypotenuse. PR square is equals to PM square, which we said we call it A. It doesn't matter if this will be or it doesn't matter if that's A. You can get the same thing. All right, now plus MR square. See, that's this whole piece here. This whole triangle here. Okay, so if we were to satisfy this, we would say then that C square, I don't want to write on this side because I really want to write on another sheet of, hold up. Let me see if I can get me another piece of paper. I don't want it. So, moving this up a little bit. So now, we could say C square is equal to, how much is 5 times 5? That's 25 plus 15 times 15. How much is 15 times 15? 225. So c squared is equals 225 plus 25 plus 225. So now we know that c squared is equals to 250. So c is equals to the square root of 250. Because it's not going to give me an equal number or an even number. Because there's no two numbers out there multiplied by itself that's going to give me 250. So I'm going to leave it at c equals 250 here. So now, they said they bisect these two diagonals. So let's look at then and plug in the next one then. So the next one going to be SQ. Because see, this one right here, we found this piece. We found that PR, this particular one here, we found that it was 250. So the diagonal is 250. We found that. So now we know that PR is equals to 250. All right, now. So let's look at this piece over here. We got, let's use this formula. Because we use this formula here to find this diagonal. We use this formula now over here to find this piece. Okay? Because they both intersecting or bisecting each other. So we got to find both of them. They crossing over. Okay? So I'm going to give you this. SQ square is equals to SN square plus NQ square. Look at it. SQ square, SQ, that's that diagonal here. SQ is equals to what? You got to take, these are your legs here. This is your hypotenuse. These are your legs. SN square plus NQ plus NQ. These are your legs. This could be A square. This could be B square. But certainly we know over here is C square. We don't know what the hypotenuse is. So how are we going to find out then where these lines are? How are we going to find that out? How do we find out what the legs are? Those are called legs. It says apply your Pythagorean theorem to it. So if you do that, you notice it's the same thing as C square C square is equals to A square plus B square. It's the same thing. They just use the size here. That's all. So SQ, you know SQ here. That is your hypotenuse. That's the longest side of your triangle here. And equals to SN, which is a leg. SN. That's a leg. That's the same thing. Okay, well, I got a B square right there. So it doesn't matter which one. We can just plug in for whichever one. And that's B square. And I did that. So let's say we just did it. Okay. So SQ square, we don't know. So we're going to stick with, we're going to say, I'm going to use the letters that they got in the triangle here. So same thing as C square though. SQ square, we know that's C square, is equal to what? What is A square? How do we know what A square is? You got to count. Let's say we say from here, from N to Q, it's what? Because it's SN square. So from here. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's 15 blocks from S to N. So that's going to be 15 square plus. How many blocks do I have to move over to get to NQ square? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I hope I'm right. Count 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it's 9. Because I pull it all the way over here. The Q sitting over there, but the dot is here. So it's 9. Because I got the Q over there and I had put it over there, but the dot is here. So it's 9 spaces. So it's 9 square. You go back and look for S. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Looks like 15. So what's 15 square? We don't know what SQ is. That's our hypotenuse. That's the same thing as C square. So SQ square equals, how much is 15 times 15? 225? Was that 225? 15 times 15, was that 225? 5 times 5 is 25. Curve my 2. 5 times 5, 6, 7. 1 times 5, 5. 1 times, okay. 5, 70. There was 225 plus, something wrong here. Plus 81. Okay. Look at that, y'all. Look at this. Did I count my numbers right? Let me see if I count. Let me count my blocks. I might be counting my blocks wrong. I'm not certain. SN. SN. Count your blocks on your, ooh. It might be, I might be having my blocks off. Let me count from this sheet. I'm gonna count from the sheet that they had in the packet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. No, it was 13 blocks according to that sheet. So I brought my line down a little too long here. So it was 13 blocks. 13. It should have ended right here. It's 13 blocks up, not 15. My drawing made a mistake. That's why I would like for you to have had your sheet that I have sent you, because it's hard to draw this on this board here. So it should have been right in here. Should have stopped right in there. Okay, so I made that mistake. It should be 13 blocks. How much is 13 times 13? Somebody help me. 13 times 13? 169. So here for SQ square, the same thing as C square, I'm going to get 169 plus 9 times 9 is 81. Add that up. See what you get. How much is 169 and 81? 169 and 81. How much is that? Somebody help me. Oh my goodness, it's 10:45. So that equals to 250. So SQ square, which is the same thing as C square, is equals to 250. And the square root, so we know that SQ is equals to 2 square root of 250. So those two sides are equal. Both of them equals 2. So PR equals 250 as well as SQ equals 250. So SQ equals 250. And so both of them equal to the square root of 250. And PR is equals to the square root of 50. Both of those came out the same. Okay? No, it's a lot. Okay. I want you for your homework to work on the next sheet that you will find on my feed. And it starts with a triangle or a rectangle the same way. I want you to work on that on your own and see what you can do with it. Okay? For your homework, that'll be for your homework. Are there any questions on how I did this today? My time is basically up. Are there any questions? If so, drop it in the box. Any questions? I'd be glad to stay on for a few more minutes if you need some help or got a question in reference to what I did, how I got it. Thank y'all so much. Hey, Miss Fitch out there. Oh, look at my people. No questions, y'all? All right, then. Do that sheet. Try to work on the other sheet on your own. Okay? Bye-bye.